In this video, we'll be simplifying this expression. We have 3 over the cube root of 54. And to simplify this, it's just standard algebraic practice to get rid of the radical sign in the denominator. So, normally, if this were a square root, it would just multiply numerator and denominator by whatever square root we saw in the denominator, and that would get rid of the radical sign in the denominator. But now we have a cube root, so we have to think about, well, what can we multiply by 54 so that we have a perfect cube? And by perfect cube, I mean those numbers that are the result of cubing something. So like 1 cubed is 1, and 2 cubed is 8, and 3 cubed is 27, and 4 cubed is 64. I think you get the picture. Let's do one more. 5 cubed is 125. So can we multiply something by 54 to get one of these perfect cubes? Not yet. Maybe we could keep going on and find that number, but there might be an easier way. Maybe we can factor out a perfect cube out of 54. So let's see, if we have 54, let's start factoring that. 2 times 27. Now we can stop right there, because 27 is a perfect cube. So let's factor this as the cube root of 2 times the cube root of 27. I'll write that. 3 over cube root of 2 times the cube root of 27. Now, 27 is a perfect cube, so the cube root of 27 is just 3. All right, let's write that. 3 over the cube root of 2 times 3. So just to be clear here, all I've done is rewritten the cube root of 27 as 3. Okay, now we can cancel some stuff out. We've got a 3 in the numerator and a factor of 3 in the denominator. So we have just 1 left in the numerator. And we would have then still the cube root of 2 in the denominator. So now we're getting closer. Now we're thinking, okay, now we might be able to multiply something by 2 to get a perfect cube under this radical. We see an 8 here is a perfect cube. So if we multiply 2 by 4, we would get 8. So let's multiply the numerator and the denominator by the cube root of 4 and see what that gives us. Well, in the denominator, it's going to give us the cube root of 8, and that's what we want, because we want a perfect cube in under the radical in the denominator. Now, the numerator is still going to be kind of an ugly thing, the cube root of 4. Beautiful in the sense of mathematics, but not a number that we are used to dealing with. But that's okay. Just in terms of standard algebraic notation, it's okay to have a radical in the numerator. So we will have the cube root of 4 in the numerator and the cube root of 8 in the denominator. I'm going to continue this up here. We still have the cube root of 4 in the numerator, but the cube root of 8 now is just 2. So we have just 2. And that's it. That is the simplified or rationalized denominator form of our original problem there. I hope that helps.